This is the solution video for question 6 from paper 2 of the 2019 TMUA or CTMUA exam. In this question, we're asked to consider this equation: cos x plus sin x tan x is equal to 2 sin x minus 1 for x between 0 and 2 pi, and we're given this, which is an attempt to solve it. And each line is labelled 1, 2, 3, this being the starting line, 4, 5, all the way down to 6. And we're asked to identify where the errors are in this solution. So we're given a few possible options for what the errors might be. So we're asked, which of the following best describes the attempt? Going from completely correct to various errors that first occur in 1, 2, 3, 4, 5, or eventually the first error is the only error in 6. So let's carefully go through this and see if each line follows from the next, and once we spot the first error we'll look back at our answers and see which matches. So cos x plus sin x tan x equals 2 sin x minus 1. So the first line we just rewrite in the question, so that can't be wrong. So now, the first line, cos x minus sin x plus sin x tan x minus sin x is minus 1. So how have we got from here to here? Well, we see 2 sin x minus 1 on the right hand side and minus 1, so we must have taken away 2 sin x from both sides. We can't see a minus 2 sin x here, but what we can see is we've got minus sin x and minus sin x, so we've just split the minus 2 sin x up, and this is just an algebraic rearrangement, so 1 is correct, so 1 is fine. So what about 2? So 2, we've gone from this to this, so we've factorised this expression. Now, to see if the factorisation is correct is slightly difficult, but what we can do is expand it. That's easier to do. So sin x times tan x, so sin x times tan x is here. Sin x times minus 1, so minus sin x, that's one of these. Minus cos x tan x, well that's just minus sin x, which is our other minus sin x. And finally minus cos x times minus 1 is cos x. So expanding this, we get all 4 of these terms are accounted for. And so this factorisation holds, and so line 2 is fine. So what about line 3? Well, we've got to this and concluded sin x minus cos x is minus 1 or tan x minus 1 is minus 1. Now, why is this the case? Well, this is sort of similar to the reasoning we use when this is equal to 0, but it doesn't work when it's equal to minus 1. For instance, one of the problems would be if both of these things were true, then we have minus 1 times minus 1, which is 1. So this certainly can't be a conclusion of the line above. So this is where our first mistake is. So let's remember that we think the method's incorrect and the first error is in part 3. So looking back at our possible answers, we see it certainly isn't completely correct. The first error doesn't occur in 1, doesn't occur in 2, it occurs in 3. So option D is the best description of what we think the solution is. And so our answer is D.